Okay, get a look at this. Try answering this on your own. So pause, read through the directions, try it, and then hit play and watch my solution. Okay, so as the question said, we're looking at the market for fireworks, and so all you have to do is sketch a ordinary looking market supply and demand for a fireworks market. Quantity is on the x-axis, price on the y-axis. Where supply and demand for fireworks intersect, we have our equilibrium price and quantity. So we have completed part A of number 3 by doing this. Part B said that we should assume that the noise from the fireworks disturbs all of the neighbors. And on our graph here, we should show each of the following. First, we want to show the marginal social cost curve labeled MSC. So the marginal social cost is greater than the private marginal cost represented by the supply curve here. We assume that all costs are already reflected in supply and demand, unless, as in this case, we're told that there are an external positive or negative outcome, such as our marginal social cost. Notice that, at any given quantity, the new cost is higher on the marginal social cost curve than it would be on the regular supply curve. So that's how we know that we have shifted supply the correct way. Marginal social costs, when they're representing a negative externality, always lie above the supply curve, and marginal social benefits would always lie to the right or above the demand curve. Anyway, onward and upwards. The second part of B is to show the marginal social benefit curve labeled MSB. So the marginal social benefit is already reflected in the demand curve. We just add the label MSB to the demand curve. We don't draw or sketch anything beyond what we have done already. And then the last part of B was to shade in any area of deadweight loss. So society wants the quantity where the marginal social cost is equal to the marginal social benefit, or quantity QS. Again, they didn't ask for this. I'm just using it to show that the private market overproduces in the case of negative externalities. To get the area of deadweight loss, we go to the equilibrium quantity the private market arrives at, and then we're going to go straight up until we run into the marginal social cost curve in this case, or if it had been a positive externality, we would have gone straight up until we hit the marginal social benefit curve, and then we would shade in this little triangle here that represents the area of loss to consumers. In part C, I'm just cleaning the graph up a little bit here. They actually want us to assume something different, that now we consider that rather than be bothered by the noise, neighbors enjoy watching the fireworks, in which case this would mean that there's a positive externality, and if there's a positive externality, that means the marginal social benefit is not reflected in the private marginal benefits of our demand curve, but instead lies to the right or above the demand curve, the private market demand for fireworks. And if that's true, then the socially optimal quantity is where supply, or marginal social cost, intersects with marginal social benefit. And as you can see, society wants a larger quantity, and they're willing to pay more for that quantity. So to answer the question, is the market equilibrium quantity of fireworks greater than, less than, or equal to the socially optimal quantity? The private market's equilibrium quantity would be less than the socially optimal quantity. And then in the second part of C, in this case, if the government bans fireworks, will the deadweight loss increase, decrease, or remain unchanged? In the event of a ban by government, clearly society does derive benefit or value from the fireworks, and banning them would eliminate all of those positive benefits, so the area of deadweight loss would increase as a result of a ban, because you would be much further away from society's equilibrium quantity, QS.